of a number give you an identity element. So what an identity element for addition is 0. So it means 5. Okay, 5 operation B. Don't know the B. The B is the inverse that we are looking for, is equal to identity element is 0 for addition. So that is if this one is divine on addition. So let's say A operation B is equal to A plus B. So we are dividing this on addition. So now to find the inverse of 5 based on the addition, we are going to have 5 operation B. B is the inverse that we are looking for, equals to 0, because 0 is the identity element for addition. So that means 5 plus B equals to 0. Then carry this 5 to the other side. B equals to what? Minus 5. So the value of B here is minus 5. So minus 5 is inverse of 5. Minus 5 is inverse of 5. Now, the last part we are dealing with is distributive. So what is distributive property? The meaning of distributive means when you have, just like associative, that one involves 2 operations. This one involves 2 operations as well. But for this to be distributive, it means what you have on the left hand side must be equal to what you have on the right hand side. So it means when we are given an operation like this, let's say you have A operation B is equal to A plus B. Now, we now introduce another operation again as A operation B operation C. So if the result we have is the same as having C operation A operation C operation B, then we say it is distributive. What this means is when you open this bracket with this, you are going to have something like this: AC operation BC. So it must be equal to CA operation CB. So if this condition, if these two sides, the result that we get are equal, then we say it is distributive. So let's look at the definition. Left distributive, you can see that A is being put in front here, while on the other side, which is this is left. Look at the right. B and B operation C is on this side, while A is on the other side. So, and you can see when we open the operation, see what we have. We have A operation, A operation B, operation B, operation C. So, we are going to solve some example on distributive, then so also on others that we have treated, they have mentioned closure, identity, commutative, associative, and distributive. Now, so let's move to the next slide. So look at this example. It says check if multiplication is distributive over addition. So this is addition. So when you have A into B plus C, so you have to check whether it is distributive. This is what is meant by that. Here we have two operations, addition and multiplication. So when you have A and you have A into B plus C, because the equal to when you have B plus C into A. When this is satisfied, then it is distributive. Now let's check whether they are distributive. Here, you have A times B, that's AB, A times C plus AC is equal to B times A, BA plus C times A, CA. Now, let's check whether they are really true. Let's assume that our ABC that we are given, A is equal to 1, B is equal to 2, and C is equal to 3. Let's check. And you have 2. Okay, sorry. I said our A is what? 1. And you have 1 into brackets 2 plus 3. Is it equal to 2 plus 3 into bracket 1? Let's check. 1 times 2 is 2. I say 1 times 2 plus 1 times 3. Is it equal to 2 times 1 plus 3 times 1? Alright, this one gives us what? 2 plus 3 equals what? 2 plus 3. 5 equals to 5. So this is distributive. So multiplication is distributive because here between A and this B plus C is multiplication that is between them. So this one is distributive. This, we're taking note of all that we have printed. Make sure you write the notes and the examples. Now let's move to the next slide. Another example. So look at this. Given operation star and this happen. So we are given two operations on here. You can see that we have been given a set. You can see that all the subjects are interwoven. We are entering set here under binary operations. So look at this. This is a set that contains 3 elements. What are the elements of the set? 0, 1, 2. So we want to test whether 2 is distributive over this. That is, this operation, is it distributive over this operation? So both sides equals to holds for this case. Now let's use real numbers. Okay, let me use real numbers. Okay, let's say we have, and they have used real numbers already. We have 2 multiplied by, I'm assuming that this star is multiplicative operation into, okay, let's just divide it and see whether it is true. So let's say A operation B, A operation B, A operation B, okay, A into operation A operation B operation C is defined as A times B plus C. Now let's apply this to a real number. So if this is 2 operation 1 operation 0, so which will give us this one is supposed to give us 2 multiplied by what do we have here? 1 plus 0. 1 plus 0 give us what? 1 plus 0. So we have 2 times 1. That gives us 2, isn't it? Now let's check the other way out. Let's just bring this forward. 1 operation 0. This is operational. This 1 operation 0. Let me shade this one too. So let's know that our operation is shaded. So 1 operation 0 operation 2. Yeah, this is supposed to give us 1 plus 0 multiplied by 2, according to the operation we are given there. So we have 1 plus 0 is what? 1 times 2 give us what? 2. So the left hand side is equal to the right hand side using this operation. So this is 2, 1. So this is the right hand side. The operation, okay, let me test the other way around. It's 1 operation this, and this is it. So the two of them are the same. So that is all about. Now let's look at this second example. We have said the operation we are given is A operation B equals to A plus 2B. So we have to test distribution over addition. So we want to test distribution on this operation we are given. So I've been given that I would like to use another operation to represent this. Maybe star. Let me use star for convenience sake. So when you have A operation B, you have been given that is equal to A plus 2B. I want to show that this is not distributive. So let's check whether it is distributive or not. So A operation B is defined as A plus 2B. Now, and you know that distributive involve 3 elements. So that means we are going to have A. Okay, let me start from the C. The third one that I want to introduce. C operation A operation B. So this is one condition. Then this is the second condition. A operation B. A operation B. Then operation C. You can see here, C come first. Here, C come last. So let's now check 2 of them. The place where C come first, we are still applying this on it. So you are going to see this C as A, then the remaining 2 A as B. So we apply this operation on it. So C operation A operation B. You know, I've told you to see this C as A, then the 2A as B. You know, we have just 2 operations here. So this one will give us what? C, that is C plus what? Plus 2 into what? A operation B. Now don't forget that this operation is still, we will still apply this same operation on this one as well. So this one will now give us C plus 2 into brackets. Perform the operation on this one. A is A now. A plus what? 2B. So if we open these brackets, we are going to have C plus 2A plus 4B. That is for the right hand side. Now let's check the left hand side. That is this one. So C for the left hand side, where we have A operation B operation C. AB here will represent A, whilst this C will represent B. So applying this operation on it, AB here that is representing A will be A operation B. Don't forget this not times. A operation B, then plus 2 what? 2C. Now, don't forget that this one too has operation on its own. So we now perform the operation on this one too now. So we are going to have this A represents A now. So A plus 2B. then plus C. So this is our left hand side. Now compare these two. Are they equal? Even if you rearrange the left hand side as C, SC come to the front, plus A plus 2B. They are not the same. And if you assume that, let's assume that the value of A is, we are just assuming now, A is equal to 2, B is equal to 3, and C is equal to 4. If you substitute this value in both left and right hand side, the right hand side give us C plus 2A plus 4B, while the left hand side give us C plus A plus 2B. So, and we have the value of A to be 2, B is 3, B is 3, and C is 4. Let's substitute the value for right hand side. On the right hand side, we are going to have 4 plus 2 into what? 2 into 2 plus 4 into 3. So now, what is 4? And this will give us 4 plus 4 plus 12. 4 plus 4 is 8 plus 12. That gives us 20. Now let's check the left hand side. The left hand side is C plus A plus 2B. C is what? 4 plus A, 2 plus 2 into B, 3. That's 4 plus 2 plus 6. What is 4 plus 2? 6 plus 6. That will give us 12. Okay. 12. So we can see that 20 is not equal to 12. So the left hand side is not equal to the right hand side. The left hand side is not equal to the left hand side. So it is not distributive. Assuming they are equal, then we'll say they are distributive. So you have to try to work on this on your own. This second word example, that is for distributors as well. So for the application of binary operation, these are the area where binary operation are being used. It is used in accounting for commutation of numbers, addition of different currency. It is used in coding, computer science. It is used in encryption of data. Do you know what is meant by encryption? Encryption means when you protect a particular data from anyhow person to interrupt it. So we use it in financial calculation, we use it in algebra simplification. But I want to solve more examples on closure identity